Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. And good morning to everybody. I believe and hopefully you are in a good health, in good mood to start your day today in the morning. So my name is, first of all, I would like to say thank you to Universitas di Ponorogo to invite me to be a part of this Kuliah Tamu sessions in this faculty. And I would like to say thank you for the Dean, Professor Adi Darmawan, for beautiful welcoming speech, and also Mr. Muhammad Badur Huda for contacting me to be a part of this program. So my name is Muhammad Nurul Azmi, Muhammad Taib, and normally people call me Azmi. And after that, I have graduated from University of Malaya for my first PhD, and my second PhD from École Polytechnique, France. So for today, I just want to share with you what we have done in our laboratory. And the first thing is about the unlocking natural potentials, MixONat carbon 30 replication strategy in nature product research. So it's mean we are using this software to determine the chemical compound exists in the plants. It depends also how we develop our database from the beginnings. So some information about myself. There's an interesting about myself. I'm just a normal person who love to do research and also to train our young people to be a good scientist. So this is about the membership. For my membership is I'm a part of Malaysian Nature Product Society, Institute Kimia Malaysia, and this is some detail about myself. Nothing much. And for research domain, they have several criteria that have been done working together. So the first one, of course, I'm doing nature products together with pharmacognosis, okay, because we need the application for that. And the second one, I'm doing a total synthesis of nature product because during my research in nature product, we have a critical problem. The first thing is the amount have been isolated from nature products, which is totally low. So in the end of this, during the journey for the total synthesis of nature product, we developed the heterocyclic chemistry to synthesize the compounds. So, okay, before we start further about this MixONat, so why nature product are useful for drug discoveries? If we realize in our blockbusters drugs tentatively coming from the natures, okay? If we see the data, this data have been isolated from Journal of Nature Products, and they show about the entity around 1981 to 2019, how the nature product contribute a lot in terms of drug discoveries. So most of them natural coming from the nature products, botanical roots extracts. Now we have around 3 what we call botanical drugs. It's mean we take in the roots have been approved by FDAs, and the rest is just as total synthesis derived from nature products. And most of the nature products coming from the marine organisms, plants, and also microorganisms. And we have to change, in terms of the research in nature product, we have to change the strategies, go to the systematic approach for that. And after that, right now we are focusing on cancer, dengue, Alzheimer's, diabetes, and tropical disease. I just want to highlight a few things important by Caporal. So when you have no idea where to begin in drug discovery programs, nature is a good starting point. So this is very important to do that because our region, Southeast Asia region, is very rich with this kind of natural resources that we can explore together. So for the sourcing of nature product compounds, this is kind of several activity that we've done previously, because previously I attached with University of Malaya, and after that I'm doing my PhDs, and when I'm coming back, I'm attached at the University of Science Malaysia. So we are doing some sample collection. Sometimes we are harvesting bark, latex. It depends on during that time what we can do during this the process. Okay. So about regarding the prospections of Malaysian biodiversity, okay, so we start the program in 1985 and we stop in 2018 because of fundings, of course. So they have several stations that have been collecting in Peninsular Malaysia because under Malaysian Agreement 1963, we cannot interpret the Borneo Island, which is Sabah and Sarawak. So we only cover in the Forestry Department in Peninsular Malaysia only cover for the Peninsular Malaysia or only. So right now, what we have already 1,100 plant collections, okay, which is cover 87 among the 57 botanical plants, which is cover the Anunaceae, Apocynaceae, Clusiaceae, Euphorbiaceae, Lauraceae, Malaceae, and Rubiaceae. It's high plant collections. So we stock the plant in UC Malaya dry rooms, okay, and after that we preparing some extract library and we send our extract to Institut de Chimie Substance Naturelle in Gif-Soivet in France. So for the high throughput screenings. And after that, we are doing selections. They have automation HPLC to do that. And after that, we found the compound. This is the common cycle for the natural product chemistry. So this one have been collaborated with the French institutes, and we hope we can share the outcome together. So this is several activities that we go to the forest, okay, and after that doing some sample collections, we harvest bark, fruits, leaf, and it depends, sometimes roots or latex, and we bring it back, we doing some drying process, grinding, recording, and keeping into our storage. So, of course, we have to determine the compound that we get it from the forest. So that's why we need the botanists to work together with us. So we have one very nice guy. It's already retired, but they are still, because the passion in botanist field, so they are still working with us. I think right now because there are no research activities regarding the sample collections, I think we already stopped this one, but he already finished several tasks to read the animal, and we prepare the plant specimens. Is very important for herbariums, and surprisingly, can you imagine, this is chemistry departments, and after that we have our own herbarium. So it doesn't make sense, because chemistry, biology is or something like that. And we have specimen library where we keep our plant specimens, and they have a lot of specimens in our collections. And now I'm working together with International France Malaysia Natural Product Labs in University of Malaya. So this is our dry sample storage. Okay, the sample collection starting from 1998 in 2010. So the part that we collect is around leaf, stem, bark, and roots. And this is the species that have been collected. Okay, this work have been in collaboration with IFM Net Product Lab, ECSN, and also University of Malaya. So if we talk about the relationship between biodiversity, chemical diversity, and biological activities, this is how it comes. So for example, this is several compounds have been isolated in our laboratory. For example, kinganin G is very important for the BCL-XL inhibitors because during that time we can isolate, we can manage to screen and doing some assays around 2 micromolars. Okay, it's coming from Endiandracum genus. And from Apenia conchegra, we managed to isolate 2 good candidate drugs, which is acetylcarbical acetate and also eugenol acetate, which is derivatized from both of that. So next, this is a kinganic acid C, okay, with alpha amylase potentials. And the last one is a burnaminols, which is a part of a alcoholite, indole alcoholite product. It's not really stable for that. So we have to carefully isolate and keep it the samples very fast. We have to do it. Okay, so for MixONat projects, so he been during that time, I'm young and very energetic during that time. I'm attached in the University of Malaya. So I have been introduced by Khalid Jawang, is my supervisors, and Mark Litodong is also my supervisors for nature products. And also Pascal Richong during that time is collaborators in Angers universities. And myself have been introduced to Severin, okay, during that time from Angers universities, and we have a good big meeting among the French and the Malaysian university. And during that time, we initiate the roots to work together in natural product chemistry. So the idea is coming from Angers University, University of Angers, which is this one. okay, University of Angers, and University of Malaya. So together with PCSN and also myself, we initiate the program. So everybody love to do natural products, and everybody declare I'm a natural product chemist. So we have a similar problems, which is time-consuming process. That means within 1 month you cannot get the pure compounds unless you have to work very hard without rest 24. No, I mean on holiday you have to come also. It doesn't worth it because our body need to rest also. So the time consuming in this natural product exploration, if we talk about the classical natural product process, especially in isolation and purification process. So, and after that, during that time with the extraction, so we get a mixture of extracts. So the strategy is in the beginnings during when I tried to start my PhDs, there have a few groups in Geneva, France, and also USA start to use LC-MS and molecular networking in collaboration with GNPS. So they are using this kind of software, MSecMine, Sirius, MedGem, and Cytospace to do some plotting and clustering the compound, which one there are possibility non-compound isolated before, okay? And possibility they have a new compound for them. So this is the idea about the replication strategies. So during the COVID, the team in Angers, I think the COVID is kind of blessed. We can lower down our research activity and start to think more creatively because we have to work very fast and at the same time find a good result. So in 2020, they start to initiate a program we call MixONat. Okay, it stands for Mixture of Natural Products. So they said how we can, from the mixture of natural product, how we can determine the possible compounds in the extract. So it's at the same time we can isolate very fast the new compounds, at the same time the non-compounds. Okay, of course we have another application for that. Okay, so this is the first publication have been published, I think, in 2020. Okay, have been by Severins and a few things. Pascal Ishom and a few teams how we can manipulate the carbon-13 data to do some compounds elucidation and determinations. So carbon-13 replication techniques. What is MixONat? MixONat is a carbon-13 replication tools. It means there are free software that can download freely, can be used, but you have to be trained. Okay, based on carbon-13 spectrums, okay, and after that, it's carbon-13 itself, that 135, that 19, that 45. So we can use that data to determine the possible compounds. And an identification established after comparison with literatures and experimental data. So after we are running the software, at the same time, we have to do some manual determination of the compounds for that. Okay, it's separately according by the type of carbons, and it's only the drawback about this one, they are only identified in compound only. At least we have something. Okay, and serve as a valuable resource for natural product research, enhancing the speed and accuracy of compound identification in complex mixture through carbon-13 based replication. So at least if they have no compound, so as we know, anybody are doing natural products, the main skeleton is similar, but the difference is what they have done during the substitution, modification of the ring or something like that. Okay, so for carbon replication, it's hard to identify metabolite. It's mixtures, save time, cost, and chemicals, environmental friendly, and with some limitation, only non-compounds have been determined. Okay, or the major compound have been determined. It depends on the carbon-13 that we have. Okay, so this is the step how we can do. First, what we can do is we create the database. Okay, so usually we found the STF database from this website, Lotus. It's very good website. If you type Lotus DB database, you can find, and after that you can type what types of the species or genus that you study. They will list down all the chemical components that exist in the particular plants. And after that, my colleagues, because create database, I don't have ACD lab, it's very expensive. So I asked my colleague, Dr. Severins, to create our database. Okay. So the second ones, of course, we have to go to the NMR rooms and we have to run together NMR data. So we run carbon 13 of the mixture, okay, that 135 and that 19, okay, to do some carbon 13 analysis. And next, what we can do is this is the interface of the software. So the software based on the Pythons is very not a heavy software. It's very like a software, so it can be installed into our website, our laptops. No problem at all, no crash. Okay, so for the first one, we have to upload the database that we create. Usually, I ask my colleague to do that, and after that, even though you have only carbon data, yes, you can run. Okay, if you have that only, yes, you can run. It's better to have carbon 13, that 135, that negative. But for me, because I'm just do some screenings, what compound exists in particular compounds, so a particular mixture of extracts. So I prefer to run carbon. Okay, at least I have some ideas, and I see my student again, and after that do some discussions how we can do what we can do next. Okay, and after that, after we click run, they will come up with the predictions of compounds. If we see clearly the score is reflect the accuracy of this prediction of compound. For example, if we see clearly this is 1, this means 100% confirmed. Okay, it's more in this case, it's most of the compound is 100% confirmed. So, but we have to do the classical analysis also, but we have to compare with carbon 13 data, experimental and literatures with the same deuterated solvents. Okay, so if the reported data run in CDCl3, so we have to find the literature, right, which is running in CDCl3, the carbon 13 data, and after that we do some comparisons. Okay, so and after that, when they are come up with this list of compound, we can do clustering based on the type of compound. For example, this one is sterol, terpenes, and coumarins. Okay, so this is an example. I have 2 cases, and I will share with you that later. So the advantage of this MixONat is a rapid dereplication, okay, because it's time consuming, time very fast, okay. The integration of carbon 13 NMR, support the depth data, user-friendly interface is very easy. I have a simulation and demonstration after this, and database-driven approach, okay, because the comparison coming from the comparison data is coming from the database that we created and the broad applications. And the thing is, it's free and open access. Okay, so if you're doing some molecular networking, some software probably need to be paid or some things, and after that, you need a powerful computer to do that. Okay, that's why we are using carbon 13 dereplication computer. Let's see MSMS strategies. So this is the process step by step. I already explained to you about what we can do. And the limitation, you have to keep in mind all strategy that we created is not 100% reliable. So it means this strategy function as a tools to do research, not as a the absolute result that we can trust. So in the end, it's depend on the scientists who want to determine the result, whether they are correct or not. Okay, so this is some limitations of these strategies. So we have to admit this one. So, but they're still on trying and error. But what we can say now, it's helped us a lot. Okay. So this is some advantage, but I just want to highlight here. This strategy is essential to combine with manual analysis and expert judgment to accurate compound identification. So the thing is, what I observe now, the young peoples, okay, so when you have tools, you trust 100% tools. So it's not really good, okay? So you have to go into the classical chemistry, which is you have to read one by one and do some analysis for the NMR, HMBC, HSQC, and so on. Okay, it's better to do that, to confirm everyone, okay? So I will go with the first projects that have been reflect what we have done in MixONat. Okay, the project have been is isolation secondary metabolites to treat dengue from Diospira species. Okay, so during that time, in collaboration with Professor Jean-Claude Guillemot from University like Marseille in France, they're doing some preliminary studies, okay, perform around 3,563 ethyl acetate extracts. from 1,500 plants, including nation plants. Okay, and during these preliminary studies, it shows that Diospyros genus has interesting inhibitory activities in dengue replications. Okay, without cytotoxic at 5 microgram per ml. This is very important. Okay, killing the dengue virus and no cytotoxics. Okay. So as introductions, okay, dengue is a disease transmitted by arthropods, which is Aedes aegypti and Aedes albopictus, caused by dengue virus. There are no symptoms. Sometimes there are flu-like symptoms, okay? As the development of this disease having severe bleedings, organ impairs, and plasma leakage, okay? So this disease is human, mosquito to human, which is a cyclic transmissions. And according to WHO, it's reported around 800% increase between 2000 and 2019. It's very serious cases, okay? And in Malaysia, our country has acknowledged dengue as a national endemic and head treat. And they have a vaccine by names dengue vasia, but the recipient acquires several forms of dengue infection due to shortcoming and limitation of trial. But I think they have stopped this trial, so because of the side effects, okay? So there is another findings used that pandrotin A and hydropandoratin A and quercetin used to treat in inhibitions of dengue virus 2 and 2 NS2B and NS3 pro protease inhibitors. Okay. So in preliminary studies, we have 4 students working on that. Solihin during that time is my master students. The result study is the Diospyros philosophy, and the inhibition is 48% inhibitions at 5 microgram per ml. And this is final year, undergraduate final year project doing by Alia, Diospyros articulata. And this is Ibrahim from Nigeria who doing both Diospyros lancifolia and Diospyros adenophora for this one. And after that, Diospyros cauliflora, my master students doing this time. So I have 2 master students, 1 PhD, 1 final year project, which is a student who cover these ones. So during this isolation process, so this is what we found, okay? And surprisingly, when I'm coming back to Malaysia, this dengue replicon assays is not established in Malaysia. So we don't have any choice. I have to find another collaborator, which is Professor Habibah Wahab, okay, our currently Deputy Vice Chancellor of Research. We shift to inhibitions of dengue protease. So in this case, we repeat the same process that is among them Diospyros porothy show 68% inhibition at 200 ppm. Okay, so and we managed to isolate the major compound, which is butylene, lupiol, and lupinols. So this is a part of introduction about this species. So it's known as a kayu arang, kayu malam, and sungkang seribu. And this is native to Malaysia, Perak, Kelantan, Terengganu, Sabah, and Sarawak. So this is the process for the common process in isolation and characterization. So we have a dry sample, we maceration in ethyl acetate, followed by methanol. So we have ethyl acetate soluble extracts. So we are doing chromatography analysis, which is column chromatography and TLC. And after that, we do some fractionations, very common in nature products steps. And after that, in the end, we are doing chemical elucidations, okay, by using spectroscopic methods. So the thing that we do is we try to implement the MixONat strategies in the Diospyros species. So we already create the database, okay, and after that, this is a DEP19, DEP135, and DEP carbon 13. So in the end of this one, so the thing that we do, and we do some input additions, and after that come up with the result. And in the end of stories, the process we have to compare with carbon 13 that we. So I'm preparing some videos how we can do some. Okay. So we add the database data. Okay, first. Okay, the second is we add the carbon-13 data during that time. I'm just doing try and error to make sure what is the major component exists in the spheros, okay? And we have to go to setting parameters. It's very simple interface for this software, okay? We click run, and they are going and matching the carbon-13 data with database that we created, okay? And okay, see, we found there's this is the compound have been probably exists in this extract. So 97%, for examples, okay. What else? Most of 94% for this kind of compound. So we have to do one by one. Okay. So at least we have a skeletal ideas what compound exists in our extracts. This is the ideas. Okay, most of them, the major component that have been isolated, which is this one. Okay. So as a result, we are doing similar the wet lab. Okay, so we managed to isolate the three major compound, which is butylene, lupiol, and lupinones. Okay. And after that, during that time, Alia want to finish final year project. I don't have enough time to read the whole data anymore. So what I do, I'm just put the carbon-13 data doing this similar process. And after that, they come up with this structure. So I compare with the proton and carbon data. It's 100% match, which is butanol. Okay, it's easy. Okay, for this one, I just spent around, I think 15 minutes. Okay, just get the carbon data, add the data, and after that compare with the literature. So it's easy for us. Okay, as a supervisor, as a scientist, time is very precious. Okay, so as a conclusion for the first projects, okay, in these cycles, okay, is coming the result coming from the MixONat. Okay, so three of us isolate these compounds. Okay, meanwhile for the outer circles, which is the big one, is a compound isolated by these four students. Okay, in agreements that this compound have been isolated also. It means we can trust also the software to help us to speed it up for NMR analysis. Okay, so this is the first project. The second project that I want to share is a recent project have been developed between me, University of Science Malaysia, and ECSN, University of UNDIP also. During that time, we are focusing on searching an anti-proliferative terpenes from Malaysia Aglaya species. So I work very closely with Prof. Unang in Universitas Pajajaran, okay, because he is expert in Aglaya species. So we are doing cell-based preliminary screenings from 66 methylacetate extracts from Meliaceae species, and 10 of them show good inhibitions of cell growth for the lung cancer, prostate cancer, and breast cancer at a concentration 100 microgram per ml. It's good, okay? At least we have, from this basis, we can start to narrow down our research, okay? So as an introduction, Malaysia is recognized as one of 17 mega diverse country. So they also 12 ranked world by the National Biodiversity Index. And our country home over 15,000 species of vascular plants. So if we say about the Aglaya is in Meliaceae species. Okay. So this is kind of some statistic about the global cancer burdens. It's keep growing every year. So we have to have at least our own initiative as a researcher to cater these kind of problems. And hopefully we can help and give some information or data that to our making policies or our scientists, our pharmaceutical companies, and so on. Okay, so there is this is the 10 common cancer in Malaysia. Okay, if we say among the women, the breast cancer, colorectal, and cervical cancer is the common diagnosed in women. Meanwhile, for the men, colorectal cancers, lung cancer, and prostate cancer. Okay, so cancer incidence in Malaysia is expected to doubles. Okay, in 2040, with projection indicating the number of new cases. Cancer cases rise 84,000 cases. Okay, So it's very worried if we say about the statistics, and because it's coming from our Ministry of Health. So during that time, what we can do, preliminary screening, from the preliminary result screenings, we select a few plants. And we are interestingly with Aglaya species. Okay, most of the Aglaya species that we study is a new Aglaya species, which is not covered by another researchers. Okay, so we know as Aglaya is a mahogany family, Meliaceae, and it's found in Brunei, India, Laos, Malaysia, Philippines, Singapore, and Vietnam. Okay, Laos, Malaysia and Indonesia. I mean, it's kind of like treasures for us, because we have a forest, dense forest, and we can have to go and explore. Okay, even the European scientists very keen to collaborate with us. So why not we are using this opportunity to be a part of these explorations. So I have 4 students now working on this one. Okay, the first one is Mustafa from Nigeria, Aglaya tomentosa. The result is very good, because it's more than 90% inhibition in terms of A549, DU145, and the MCF7s. And this is our local students, very bright students, Kuliah Dereplication. So this is only one publication published in 1994, if I'm not mistaken, by our group also in So, but we hope that we can explore more about this one. So, Dereplication is a new plant, no publication yet. So it's a good exploration for us. Okay, right now we managed to isolate around 22 compounds, new skeletons, and also 11 already solved. So we keep silent about this one, and we hope that we can publish this result in the beginning of next year. So another one, Nazir, is very good student. So Aglaya rubiginosa from Nigeria. Okay, and last one from Ghana. Okay, Aglaya malacensis Abdurrahman. Okay, or Titus, what we call. Okay, so during this one, before my practice, when we try to give the plant students, so I have to do as a supervisor, I have to take a responsibility, do some literatures and so on, because in the end of stories, I will defend my students. Okay, so this is what I found. Most of the compound have a lupin types, cycloartan types, damaran types, or secodamaran types. It depends. Sometimes you are correct, sometimes you are wrong. At least you have an idea what possible compound I manage will be isolated in this particular case. So I'm doing the same thing. So this is an example, Aglaya odorotacima. Okay, so I'm ask my colleague to prepare some database, and I get a database, and after that, I put inside the software, and I already have a carbon 13 data for the crude extracts. Okay, so we take time. So okay, and after that, click run. It's very simple. Okay. Okay. The result is based on our database created. That's why you have to find and make a good database to make sure you manage to isolate the compounds. Okay, so let's take time. I'm really sorry about that one. Okay. Okay, this is the possible compound that we think we will isolate. So we have to go to the wet lab and doing some analysis. As I said, yeah, correct. Because most of the skeleton exists in this one is come up with my analysis in the beginnings. Okay, and after that, this is the result for that. Okay, so this is the result for that. So from the proton NMR also, we realized they have a lupin skeletons, damaran skeletons, and cycloartan skeletons. So we are really happy with that. Okay. So this is the compound have been isolated. Okay. So the first compound, is cycloartan types, which is these compounds, which is this color have been represented because for example around 3.2 ppm is reflect for the proton in these positions. And this is a very typical peak for the cycloartans. If you find these two peaks, okay, so it's represent for these protons, okay? And this proton is represent for this these double bonds here. Okay, and if we talk about the carbons, they have so many ideas, so many information that we can analyze. For example, this one, the CH carbon in this position close to the CDCl3, and this one is the almost quaternary carbons, okay, because there doesn't exist in depth 135. And the rest, this is the double bond, which exists around 125, okay, and this one is this carbon also. So this is the information, slightly information about the cycloartan skeletons. So this is a very interesting. In the beginning, I think because this one in my mind, this is a lupin type carbon. So when I try to solve the structures, it's not lupin type. It's a secodamaran types compound. It's a damaran types, but this carbon ring number A is openings, and they are become secodamaran. So if we see clearly the proton in these positions, okay, the proton in these positions, which is located in these areas, okay. And if we've talked about the carbon 13, so there are so many information that we can understand. So for example, this is carboxylic acid carbon, so it more to around 180 ppms. And if we see this one is the CH2, because it's a negative mode of carbon 13. So they have a CH2, and this is the quaternary carbon, because this doesn't exist in the depth 135. And if we see clearly, there has another quaternary carbon exists because there's only one carbon exists, okay? So this is the quaternary carbon, and the rest will be in this position because it doesn't exist for this one, okay? So, during this process, we managed to isolate another isomer, which is this one at the back, proton at the back, but we managed to isolate the similar choric acid, which is at the front. So the different, how we can determine the difference, because this carbon values is around 86.0 ppm. But if we talk about the choric acids, this carbon, when proton at the front and the substitutions at the back, so it's around 83.0 ppm. So the proton pattern is similar, but the difference is we can say in the carbon position. So it's very interesting when you do nature products, because only natural product chemists can read the complicated structures. Okay. So this one is a cycloartan types also. So, but the thing is, we have another substitution in this position. So this is very important and very nice to discuss, because of it is CH2, which is this one, and this around 3.25 is exists for the proton in these positions. And again, I just want to highlight, if you see this peak, these two peaks, is of course they are represented cycloartan types. And again, the rest you have to read the carbon NMR also. So this is what we found during that time. So this is a CH2, which is carbon at this one. And of course, because they have OH here, we have this peak around 76 ppm, and the rest one is a carbon functional groups. Tertiary functional, tertiary carbons for that. So as I said, if you see the choric acid and the rest, it will be similar, but this is the lupiol and this is the lupinon. The difference, we can see the difference, the separance of this proton, which is this one, is reflect, because the difference is only, this is OH functional groups and this is ketone functional groups, okay? So if you want to see whether your compound is lupin type or not, this is a very typical peak for the lupin types, okay? If you see this doublet here, okay? So during this process, we are very surprised. We managed to isolate the olin types. So this is very nice NMR during that time. So we try very hard to do that. And with the help of our colleague, Dr. Naini from BRINS, Prof. Unang from UNPAD, and also my colleague from Gitang from Institut de Chimie Substance Natural. So we come up with these structures. It's very useful structures, you know. So if we see very nice structure for that. It's like olin types, like beta amirin, something like that, alpha amirin, okay? So if we study carbon 13 and also DAP, we can see we can do some matching in the important peak for the carbon 13. Okay. And this is the new compound that I have been discussed. So this is cyclohexanol. The funny thing is, in the beginnings, I found this one okay, cycloartan, but quite surprised because I saw this one because when we are doing some literature, there doesn't exist this one. But after the long discussions with Dr. Naini from Brin and also Prof. Hunangs, we come out this compound is 29 nor cycloartan. It means the disappearance of one methyl, 29 methyl in these positions. So that's why we call carbon 29 is disappear. For this one is become only single methyl functioning group. So we are doing some analysis for this, and after that we come out. This one is very nice to elaborate and discuss about this one. Okay, so right now what we can do now is a biological activity. So we are in process to determine the structure for another cycloartan, not cycloartan, nor cycloartans. So in hope that we can find, I think it's around 2 or 3 new compound for that. Okay, we are still hope that we can manage to do that. So as a conclusion for the second project, so this is the thing that we come out with from the carbon dereplication, which is coming from the MixONat, and after that, this is coming from the isolated compound. Surprisingly, what they are propose have been isolated also in MixONat software. It means what I can say, software MixONat software is very helpful to us because I don't have to spend more time to read the NMR data. I mean, I think for the first compound, I think I spent around 3 hours to do that. I think it's good 3 hours rather than 1 whole day because our duty is teaching and also another admin post. Okay. So there is slightly the ideas have been throwbacks. What if we combine SCMSMS dereplication strategies and also MixONat, which is carbon 13 dereplication strategy? This is the ideas. And now with the collaboration with France, we try to initiate the ideas and make sure these ideas have been visualized. Okay, so we try to combine MixONat and also molecular networkings. It's a complementary strength and it's very good, okay, because SMS is based on MS, carbon 13 based on the NMR data. We combining is a faster and more targeted isolations, okay. So in summary, what we can conclude, MixONat and molecular networking, is that the big data? Yes, most of them is the big data because we are playing around with IR 4.0s now. So is that AI based? MixONat is a semi-AI based because they based on our database have been created for us. But for the molecular networking GNPS, yes, it's a machine-enabled tools. Okay, because it's dependent on the software that we download. And for carbon 13, MixONat is a fast dereplication using carbon 13. But meanwhile, for the GNPS, is a MS based. But combining molecular networking and MixONat is reflect multi-dimensions, AI enhanced big data approach to rapid and intelligently identifiable active compound, reducing redundancy, enhance novelty, and accelerating discovery in nature products. For example, like cases of Najia, I think for the 6 months, she just registered. For the 6 months, we managed to isolate 22 compounds. We solved 11 compounds. So it's very fast, you know. So it's very good, okay. So I would like to say thank you very much to my previous supervisors and my mentor, Professor Khalija Awang from Dr. Mark Litadon, already retired this year, Fanny Rossi, Sandy, Florent, and Cecile from Institut de Chimie Substance Naturelle, Professor Richom and Severins who helped me for MixONat and also database, Ivansis, Samezad, and Laurent and Hakim, which is my supervisors and my collaborators in Laboratoire de Synthèse Organique, Polytechnique, who contribute to this project also. So this year I have been the recipient for the My Tiger between Malaysia and France grant. So I hope that I come back. This one, my travel last year to initiate the project with the team in Institusi Misabstang Nancuran. So this is all the collaborators have been working together. We are very hard to do it, and very happy for Prof. Unang also as for me is my mentor also in Malaysia species. Okay, so this is my team. I think this is quite old picture. I think taking last year. So most of them is already graduated. Yeah, but people go and the only one stay here. Okay, so this is my lab and laboratory of natural product and synthesis organic, what we call NPSO. This is my details, and if you want to know more about my team, you can write in Google's NPSO lab. Can go to enter. I'm preparing some videos and for students to explore. So we are happy to do that. Okay. Thank you very much for your attention, and thank you again. If anybody want to do MixONat, it's a free software. Okay, so just install and try to explore. Okay, so thank you very much. Merci beaucoup. Terima kasih banyak-banyak atas semua perhatian yang diberikan. Terima kasih. I give back to Mr. Muhammad Badrul Huda. Thank you.
Yeah, thank you very much, Prof. Asmi, for that insightful and informative presentation. Very interesting about MixONat software and molecular networking. We can new compound from isolate in natural product. Now we will open the floor for a question. Please type your question in the chat box if you have a question, and you can in chat. Okay, this one question for Kabir Basir. Oh, thank you, Doctor, for the wonderful presentation. Please, it is possible a student that is not under your supervision to join NPSO group?
Is it possible for students that not under your supervision to join the NPSO group? So what do you mean? You want to do attachment, or I don't have any ideas. So maybe we can discuss more further about this one, because I'm not sure what do you mean about that. So I almost welcome people to join it. But this year, for example, I'm welcoming around 5 Indonesian students and also three or four Nigerian students. So from Win Bandung, 2, from UEE, I think 3 persons. So we are happy to welcome more students. I saw Zul Masri here, Pak Pinos is also here. So it's a part of my collaborator to do that. Okay. So in this.
Okay, and then the next question is, in the NOR spectrum, I saw some peaks that are 2 hex and scattered. What do they represent?
What do you mean? Which NMR spectrum? So I just want, maybe I can share the slide again. Okay, which spectra it means?
Maybe Mr. Kabir Basir can what the slide?
Which NMR you means?
Yes.
Yeah, let me share this one. So which NMR spectra you mean? I have a lot of NMR spectra. This one? No? Is it here? Because I just want to know.
Good morning, sir.
Yes.
Yes.
Yes, I mean this longer peaks. I can see some smaller peaks under.
In proton or carbon 13?
No, at the proton.
Okay, this one.
Yes.
Okay. So this is maybe I can answer this one. Okay, this is the common typical pattern for the tritopene, because they are unsaturated carbons. They have a lot of protons. When they are coupling each others, they will show like this. So normally what we can say, this is represent as a multiplex signals, but this one, these 2, these 3 and 4, we can easily determine based on the correlation of the 2D NMR. For this higher peak is represent of the methyls. So we can know how what is it's represent if we do the integrations, and we can find a number of proton exist in the particular peaks. So it's depend on the typical patterns for this one. Also, they have this one is represent of the unsaturated areas. It's very typical for the terpenes skeleton. Terpene compounds usually show like this. For this peak, for example, this is the carbon CDCl3 peaks. Okay. So the next questions. Oh, Pak Pinus, you want to ask?
Can you hear my voice?
Yes, Pak
Yes.
Pinus.
sir.
Okay, thank you. If I ask me, it's really nice to meet you again,
Yeah,
even
me
though
too.
it's in virtual.
Yeah,
Thank you for the visiting lecture that have given to us, and it's give a new insight and about using the 13 carbon NMR for well, I can say that it's kind of a prediction, right? The prediction using a database. From well, you already mentioned about the drawback of these methods because on limitation. I would like, I'm really interested in using this as because in your database actually is most of the compound on the database usually is from plants, right?
Yeah.
And I work also in marine natural product. I'm just wondering if it is probably in the future can be developed into the compound that is from marine, for example, because as we know that marine natural products also give a contribution from the natural product as because I'm really interested, with this kind of prediction. And also there's one thing that I remember that well we still have the sample that in your lab, and then I'm just thinking we are using this MixONat for predict the prediction of the sample because of maybe because it's a limitation of the isolated compound. Is it possible for doing that using this MixONat to predict the compound that we've already isolated? Thank you, Asmi.
Okay, thank you very much, Pak Pinus, for the question. So maybe they have two questions there. Maybe I will answer the first question. Is it possible to use the marine nature product in application of determination of compound in marine? Yes, you can do. But the first thing, as I said, I already highlight about this one. So you have to develop the database. So the database is coming from the Lotus. This is the easiest one. And we can have to download the SDF file, and after that converted into database, which is feed with our software. Or if you have a SignFinder N now, so you have to download SDF file also, and after that convert it. But it's depend on the database that we have. So that's why the most important thing that you can do is create the good database. To do that, I'm still doing a try and error because I'm using the Lotus database, because Lotus is not really many compound have been added into database because there is a very limitation. At the same time, it's a free. So imagine the free works is depend on the person who are free volunteer to do and upload the database, the information in database in Lotus. Okay, so this is the first one. The second one, okay, so is it possible to run for your compounds? Yes, but the problem is your compound, which is we said this is pure compound, is very minor. I already run, to be honest, I already run 24 hours because our limited time for the carbon is 24 hours. We already run 24 hours. The intake, because the noise and signal ratio, I have a problem with that because I still declare the peak as a noise, not a signal. So I'm not really sure about this one, whether we can do for that. But for the previous compound have been isolated by Zol and also Adi, so we managed to determine the compound very fast during that time. So if you remember the major compound that with the sugars, rhamnose or something like that. Okay, I hope the NMR is still in progress now. So because we are trying and error for that. I hope we can discuss in detail later, Pak Pinos. Okay, thank you very much. So anybody want to ask? We stop sharing here. Okay, so.
Okay, thank you, Prof. Asmi. Thank you, Mr. Pinus, for the question. Any other question for everyone, for the audience, for the student, Diponegoro, Universitas Diponegoro? You can
You can
question
ask in
Indonesia.
Indonesia.
Yes,
Yeah, I try to understand, but yeah, we are in satu rumpun lah. No problem.
yes.
So
I
I
think
try to.
Prof. Asmi understand if you use Indonesian language.
Yeah, sure. Boleh, no problem.
No problem.
Yeah.
Please. You
No.
can raise hand. Okay, no? Okay.
So for my side in our lab, so we are happy to welcome everybody to work with us, for example, for attachments or so on. But to make sure we want to reduce the cost of this mobility or something like that, we have to make sure that we have a MOA or MOU because they will waive our bench fee. So if we don't have any documentation like that, so it will cost you a lot. So I just want to highlight about this one, and I'm open for the collaboration. No problem, inshallah.
Okay.
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 Zero.
I think any other question for the audience? From Prof. Bambang, maybe? Or okay, ada. Teh Naini.
Halo Dr.
Oh,
Asmi.
yeah, yes.
Okay.
Halo Mas Badro.
Hello,
Nice to meet
Teh
you.
Naini.
Okay, so Dr. Asmi, I just heard about the MixONat, so this is very interesting for us because previously we also have been trained by Brooker to help us to determine the NMR.
Researchers by using
using
4.0s and AI.
using CMC
Oh yeah,
SE.
yes.
But it needs like the molecular weight first, so it is very difficult for us to use that software. So if we can work with the MixONat, so it is more helpful for us. But my question is, so for the MixONat so far, the database is only from terpenoid class or other classes have been added?
Okay, so what we do now, so we already have based on Lotus database because it's free, we download the SDF file and after that we convert it into a database that's suite with our software. So the all compound isolated from Aglaya species already contained in our database. So if you want it, I can give it to you. It's free. Don't worry. Okay, this is the thing that I've been discussed earlier with Prof. Unang because during the conference early this year, we tried to introduce this one. Seriously, it's very helpful for us because at least in our brain, our minds, as an organic chemist working on structurals, we have this peak or become represent on this peak. So it's very fast. This is what we work with Najiha, Dr. Naini. So if you remember my students and. So she is very good. For me, it's very yeah. So I think on June we already start to teach our students to use this software, and very fast, in terms of process. Yeah. So just for example, I just contacting you to confirm the structures, right? So it's become the work is getting easier, you know, compared to reading from scratch.
Yes, agree. So maybe I need to follow the training, Dr.
Oh
Asmi.
yeah. I'm happy to do that. But
Okay.
yeah, it's free software. Don't worry, it's free.
Oh,
This is what Europe doing now.
this is free software, Prof. Azmi,
Yeah,
and free access for
free
we.
access to everybody. You know,
Okay.
as long you have Windows, MacBook, no, sorry.
Oh, Windows.
Yeah, it's expensive
Okay.
for MacBook, so that's why we are using on the MacBook, PC, Windows. I think I already explained to Zol, Pak Pino, Zol, and also Adi about this software. So I don't know when they're going back there, download the software or not. So I'm not really sure about that one, but I give everything I have to the students, you know, try to explore. Oh, Pak Wahyu pun ada. Selamat, Pak. My student, Wahyu.
Oh,
Assalamualaikum dokter.
Yeah.
okay. Any question? Kang Wahyu.
Mantap nih Pak Wahyunya 18 publication master PhD.
Yeah, thank you very much, Mas Badrul, and thank you very much, Dr. Asbi,
Okay.
for your presentation. But maybe I know this MixONat software in here in May, on May, oh yeah, May 2025. But I want to ask you about how to attach the database to Lotus software for the MixONat software. Maybe only this question.
Oh, okay. How to upload the database
Yeah, yes.
to the
Yes.
okay. So
To
maybe
Lotus is.
should I do a demo or I should show the videos again? So maybe I can share the video again. Okay, so I didn't know what to do. So because I need time to open the software, so but maybe I will show you this kind of okay. Maybe this one, maybe this one. Okay. So this is for Aglaya orotasima. So we have first we have the database having created by my friends. Okay. The second one, the carbon-13 data, which is already converted into CSV file in Excel. So this first row is for the database. So we click the browse and we find the location where we store the database. Okay. And the second row is the carbon-13 data, where we store the carbon-13 data, which is already converted to CSV file. So I will play this one. Hopefully it doesn't take too long. Okay. So first we upload the database. So find the location where the database is located. Okay, so this one. Okay, already database. This already database. We already have database. And the second one, we have to upload our CSV data for the carbon-13. So we have to create our own carbon-13. Okay. Okay, this is database, and this is carbon-13 data, which convert into CSV. And after that, we click run. So they keep running. We can do for the mixture compound. No, we can do for the mixture extracts. We can do for the fractions. We can do for the pure compounds. So if we are lazy enough, for me, I'm quite lazy. So I just put the pure data compound. So they are comparing with the database already prepared by our colleagues. So right now we already have 6 or 7 database. Okay. So they come up with the result. So for example, if you see clearly, okay, the rank. So the rank with the first one. If you see score 10, it's mean 100% match. Okay, so among 30 carbons, they say 30 carbons is already matched with the database. Okay, so if we see clearly, okay, for this one, this is cycloartan, this is cycloartan. What else? This is diterpenes, sesquiterpenes. still 100%. So the limit is 0.7. The confidence level is 0.7, 1 to 0.7. This is the confidence levels for this software. So in the end of story, we still have to do some elucidation, but quite fast because we already have the reference, we already have the data, so we just click, and after that come out with the conclusion.
Oh, so only we only upload the file using the CSV format, or we can upload with the FID format?
No,
on the-
CSV. We have to
CSV,
convert
only
to CSV.
Okay.
Because CSV is very cheap because we are using Excel.
Yeah.
FID, they have another supplement file if you work
Yeah,
with broker.
Oh,
Okay,
yeah.
because previously I worked with broker and I worked with Joel. So broker is a good one compared to the Joel. Okay.
Okay. Thank you very much.
Welcome, Wahyu. Good luck, Wahyu. Okay, I'm happy for you. Don't worry.
Okay, thank you very much, Kang Hayu, for the question. Thank you, Prof. Asmi, for the explanation. Any other question? Maybe we can try the MixONat software. Oh, okay.
Ya,
Prof. Bambang, silakan.
Oh, yeah, Prof. Bambang,
ya,
yes.
ya, terima kasih. Ya, my English is not so good, Dr. Asmi, because
It's okay,
no
Pak.
problem.
I come
Boleh dalam
from,
bahasa Indonesia pun boleh tak? Bisa, Pak?
yeah,
Bisa.
I come from Marseille aussi.
Ah, Marseille.
Parlez bien français.
Parlez français?
Yeah.
Oh yeah, c'est bien,
Yeah.
ouais.
Yeah, still now, because well, Prof. Asmi, ya, dan Pak Muhammad Badrul, alangkah baiknya kalau online gini kelihatannya agak sulit ya. Pak Badrul, saya kira nanti bisa apa namanya membuat suatu pelatihan 2 hari begitu. Kira-kira bisa nggak ya, Dokter Asmi ya?
Ya, sekarangnya saya agak sibuk sebenarnya. Ada pemohon daripada Pak Badrul, tapi saya
Ya,
sibuk.
one day aja kalau misalkan
Maybe
ke
next year, Prof.
ya, saya
We
kira
can-
untuk
Insyaallah,
pelatihan.
kita tengok tahun depan lah, insyaallah.
Next year,
Ya,
insya Allah next year.
apa yang harus saya persiapkan gitu ya? What I must prepare for this pelatihan ini ya. Kalau saya punya 5 ekstrak tanaman dari spesies dari dari golongan yang sama, khususnya Hyptis gitu ya. Ada Hyptis pectinata, Hyptis capitata, etc. I have 5 ekstrak ya. Apa yang harus saya lakukan ya untuk supaya ini bisa teridentifikasi anti malaria, khususnya untuk anti malaria ya. Itu yang pertama, informasi pertama. Terus kemudian yang kedua adalah kita punya NMR juga, karbon 13. Kalau misalkan nanti diadakan pelatihan di UNDIP itu saya kira tidak jadi masalah juga ya. Sebagai model saya kira nanti bisa untuk 5 ekstrak yang sudah saya usulkan tadi. Beberapa riset sudah kita lakukan untuk anti malaria terhadap Hyptis ini, khususnya Hyptis pectinata. Sementara Hyptis yang lain itu belum belum kami lakukan ya. Apa yang harus kami lakukan agar ini bisa menghasilkan satu produk publikasi? Thank you very much.
Terima kasih. Can I reply in English or bahasa?
English, I think so.
Okay, so thank you very much, Prof. Bambang, about the question. So the first question asks, if you want to initiate this program using MixONat, what the partner have to do. So in my suggestions, Prof. Bambang can do carbon 13 NMR. So make sure you measure from 0 until 200, 220, 230, the regions. Make sure you have a very nice carbon 13, even though they are mixtures, okay? So this is the first one that you have to do, carbon 13. Carbon 13 is enough, okay? Because my big concern is if we request more experiment, you have to pay more. This is my mind, okay? So first thing that Prof. Bambang have to do is preparing the carbon 13 NMR and send the data to me, because I just want to run to make sure the process is okay. The second part that I have to do, I have to create database. So for that, I have to contact my colleague in Angers okay, to create database because I don't have ACD lab because it's expensive. So I have to ask my colleague to prepare the database, and I have to check in Lotus whether they have the compound isolated from that particular species or genus. It's better to find from genus because it's broad. If we find for the family, it's too broad. So we have to narrow down. It's like a funnels. We are in the middle. On the top will be the families. The second one will be a genus. The low one is a species. Species is too specific. Sometimes they are not isolated from that particular species. They are isolated from another genus. So it's better to start from the genus. So this is what I have to do. So if you are really serious, Prof. Bambang, maybe I can help you. We try one at least, okay? We can try one. So just email me the name of the plants. So I have to find and create the database first. And I have to discuss with my counterpart in France because they have the ACD lab. We don't have the ACD lab. So in the end of story, we have to share the outcome for that. Is it okay, Prof. Bambang? Okay, so for training in-house in UNDIPs, I'm not really sure I can do it, but I'm happy to do it because we already have the module for that. Okay, because I teach, it's better to have a module and I can teach my student to do that. So everybody can go and check again what we have done. So anybody for the young people who love to do nature products, just explore my website. They have NPSO channels. I show everybody how to do PLC, NMR, preparing NMR samples, how to process NMR using NMR softwares, and so on. So it's better, if your supervisor is quite busy, you can do some early exposure with that particular. It's free. Lillahi ta'ala is free for everybody, you know. So I'm doing for fun, for myself, you know. So I just want to give it to society. Okay. So I hope it's okay, Prof. Bambang. So I'm happy to work with you, everybody in UNDIPs, you know, because Prof. Unang is my good mentor. So it's helped a lot, you know. I learned from him a lot, you know, because I start meet Prof. Unang in 2010 during my studies. You know. Thank you very much. Okay.
Thank you, Prof. Asmi. Thank you, Prof. Bambang. Maybe next year we can schedule for the
I will try my best because my daughter will be face the big exam, so I'm not sure I can travel a lot or not.
Okay. Okay, thank you very much for the question, Prof. Bambang. Any question for the audience? If any other question?
So before we finish, I
Yes,
just want to
yes.
thank you very much again to UNDIP for the preparation for this seminar. I know we have some delays, you know, sometimes negotiation about the time and durations. And I would like to say thank you to my student also who have patient with me during my journey as a researcher in US. Okay, so I'm going back to Mr. Badrol. So if anybody want to add and ask again, feel free to email me, and I will try my best to facilitate everybody, inshallah.
Okay, thank you very much, Prof. Asmi, for the interesting presentation and insightful. I first heard about MixONat software. This is very interesting for discovery in natural product chemistry. I think if it is enough finish for the session Q&A. If there are no further question, I would like to thank you for Prof. Asmi for sharing his knowledge with us today. Thank you to all participants for joining the session. I hope we can collaborate on any other project or event in next year maybe. Okay, maybe we can I will contact Prof. Asmi if next year we prepare about MixONat software in Universitas Diponegoro.
Inshallah.
Thank you very much again, Prof. Asmi. Thank you very much, student chemistry department in Universitas Diponegoro. Thank you very much for Prin, Denaini, Pak Binus, Kang Hayu, and other audience. Assalamualaikum warahmatullahi wabarakatuh. I will back for the MC.